Alright, so obviously I've said the word Arduino a bunch of times. I haven't thoroughly explained what it is. We're going to get into that now. The core concept is that it's kind of a small computer that you can upload your code onto and have your code run. If we take a closer look at it, it's a little intimidating. There's a lot going on. First thing I want you to understand is digital versus analog. I think we've all seen a digital versus an analog clock. Digital works in kind of fixed steps versus analog is continually moving along. So think about the hand on an analog clock, right? A physical clock. The hand moves to every possible time as it moves its entire way around the clock. Versus digital, it kind of jumps, from 6:30 to 6:31 to 6:32. It doesn't hit the times in between. So that's how data is represented, because we don't have infinite storage. You can't have these weird fractions that go really small. So you'll see on these pins, which are the holes, these are called pins that go up and down the side of the board. You have these digital ones and you have analog ones. So analog is usually for conveying more detailed information or data if it needs to go back and forth. Anything that's not just going to be on or off, right? These digital pins, it's generally going to be it's on or it's off. Versus analog, you can kind of have a larger range of value, right? You can see the way it works is it pretty much measures the amount of voltage, and it can be an output or an input. So not of critical importance, but we're just going to go down through all the pins. 3 volt, this is a power supply, right? So think of the positive end of a battery. If the Arduino is being powered, it'll also put 3.3 volts here. So if you have something that needs that much power, it's very common. You power it out of that, and you wire it back down to ground. Ground is the negative terminal. You can use any of the grounds. All of them do the same thing. There's nothing particularly special about them. 5 volts, same thing, but it's 5 volts as an output. Nothing else too special about it. This one's different. It's V in. That's voltage in. 5 volts. So if you're powering the Arduino via a cable, like plugged in here, then this will supply 5 volts out. But you can also have a power supply, I think anywhere in the range of 7 to 12 volts. I don't know off the top of my head. I'd have to Google it. That you can plug into here and then plug the other cable in the ground. That will also power the Arduino, right? So if I have some sort of external battery that has wires coming out of it, I can plug it into these pins and it will power the Arduino, which is cool. So these analog pins, you will usually program them to either be an input or an output. That'll make more sense as you see the code, but this is for either measuring something that can be of varying voltage or an output that is of varying different voltage. It's not just going to be on or off. So you have 6 of those. These pins you don't need to worry about. They're for more complicated projects. Same with the other ICSPs. To be perfectly honest, I don't really understand them, and that's fine. It is abstracted away from me, and if I really wanted to learn about them, I could probably Google it, but I've done everything I can without them. Maybe there's some stuff that you could do with them. That's kind of up to your discretion. TX and RX, again, you don't need to know specifically what this is, but any sort of communication that the Arduino is doing with the computer via the cable or via these pins here, 0 and 1, you can see the TX0 and the RX0. Whenever it's communicating in either of those ways, these pins will light up. So T is for transmit, R is for receive. So if it's receiving a bunch of information for the computer, this light will be flashing. If it's transmitting, you'll see this light flash. So it's helpful to just know, like, if I'm trying to upload something to my board and I'm not seeing this light go, chances are the cable's not working properly, right? Or something's going on because it's not even getting to the board. And these pins can also be used for that purpose. That's a little advanced. We're not going to get into it right now. The reset button, if you press the button, it just cuts the circuit. So if you have it plugged in to a power supply, it'll just start running the code. And if you press the reset button, it'll cut the power for a second, so it'll restart and it'll run the code from the beginning again. IC2C and IC2 data, we're not going to get into those again for more complicated projects. Another ground, it's just simple. If you have a power, it eventually needs to get to a ground. There's just another one here for your convenience. These 13 pins are all digital, so they can read a essentially yes or no signal. Is there a quote high voltage, which is going to be 5, or is there a low voltage, which is going to be 0 or close to it? You just have a bunch of these. Also, a lot of them have secondary purposes that you can use for other things. That's going to vary by project. The one I would say be careful with is these ones are also used to communicate. So if you're trying to upload a project and you have something plugged into 0 or 1, it can sometimes interfere with the communication and it won't be able to communicate properly. So if you're trying to upload something to the board, I'd recommend if you have something plugged into these 2 pins, you take it out, you communicate with the computer, and then you plug it back in, you reset, and it'll run your code. So the pins are used for the projects. You put the wire in the pin, any sort of other electrical connection. All right, so super simple starter code that we're looking at the IDE here. It's mostly based off of C++, which hopefully you have some familiarity with. You've heard it before. It's also very similar to Java, which I know a lot of people start with. So this is the code on your main computer that's being written, and we're going to go through this one step at a time. Again, if you've seen C++, this should all be familiar. This hashtag define is a keyword, which means it's a special word reserved to indicate something. For here, it's going to be a name that you make. So they pick LED 13, and the comment, the pin LED is connected to pin 13, which makes sense. So it's good to document everything in your code, because especially if you take out all these wires and everything and try to do your project again later, it's kind of instructions about how to do the wiring. So we're just setting pin 13. The other way Arduino works, which is different from other kinds of programming, is you always have a setup and a loop function. So it calls setup once at the beginning, and then it just calls loop over and over and over and over again. So if you have code that you want to execute, it's usually going to be in loop. Setup just sets it up, right? So pin mode LED output, we're not going to get into exactly what this means now, but if you just read the comment, it just sets up LED, which we know is 13, right? It's setting pin 13 up as an output. And then loop digital write. So digital write, it's going to be either writing a 1 or a 0 to the LED, and high. So that's going to be 5 volts coming out of it. So you can see 13. This 13 wire is in the breadboard, and the way this breadboard works is that each 5 pins in each column are all connected electrically, right? So it shows these little green circles. This resistor is technically connected all the way down to this wire, and the other side is separated. So these 2 sides are separated. The wire is not interfering with any of these holes here. And the holes work similar to the pins on the Arduino. You just plug things into them. So it goes into a resistor. Notice the resistor is before the LED, because if this wire somehow accidentally went here, it would fry it. It would probably supply too much power, and the LED would, have a bad time with that. One of the legs of the LED is going to be longer. That's the positive leg. You don't need to exactly remember it, but the electricity is flowing from pin 13 through the resistor, then in through the LED, lighting it up, coming out the other side, and going to ground, right? There is a complete loop here, and it has resistance. Great. We love both those things. So playing around with this and setting it up, you're going to encounter a lot of bugs, which obviously, funny programming joke, I have a bunch of bugs. But there's just a ton of things that you might need to do to set it up, and you need to be flexible, and you need to be willing to read stuff on the internet that will be very helpful, and sometimes it really doesn't take that long. Especially setting it up, you have to set up the board. You have to pick the proper model for the board, the processor, the port. I'll show you the IDE later when I actually go through and set it up myself, but just know that there's going to be a lot of issues that come up, and if you Google them, a lot of them have been experienced by other people, and a lot of them have been solved, right? Improper board settings. This is a sample of what the IDE looks like. You'll have all this weird stuff going on, right? There's a bunch of things that you can select from the menus. It happens to people all the time. Just be willing to read a little bit online. You can usually figure it out. The other thing is, this is an example of a forum where someone asked about this STK500 error. So it's generic. It happens all the time. These are some solutions. And if we look at some of these, I had this problem on my Windows machine. The problem was simply drivers. I had not installed the drivers from our Arduino yet. It's simple. It does not take long. It just takes you to Google it. You can also see there are so many different issues that I could not possibly cover them all. As long as you keep Googling and you are persistent, the issue will be solved, and it usually will not take long. So just know that you're not going to get out of the box. You're probably not going to have it running in the first 5 minutes, but it also probably won't take that long. And then once it's set up, you never have to worry about it again. So now we're going to start getting into other parts.